Okay guys, so today we are graphing and doing transformations with what's called rational functions. Rational functions are today. Any number that is rational is a fraction. And when we were doing rational exponents before, it's when we had exponents that were fractions. So when we say rational, we're talking fractions. This entire chapter is fractions. And these are going to be fractions you can't type in the calculator.
Well,
So we really got to be like thinking about our fraction.
Can we just skip this chapter and say we'll come back to it, but never come back to it?
All right. The parent function for this rational function is 1 over x. That's the parent function. And what we can think about is 1 over x is the reciprocal of x. 1 over x is the reciprocal of x. And I'm going to talk about reciprocals a couple times when we start graphing these. Graphing simple rational functions. A rational function has the form f of x equals p of x over q of x. P of x and q of x are polynomials. So we're going to do binomials, but they can be more than just binomials. But we're going to do binomials today for the top and the bottom. Okay, when we graph it, it will always look like this. These are called hyperbolas. There's hyperbola. 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 Nope, that's English. This is hyperbola. And it says that it consists of 2 symmetrical parts called branches. So there's 2 parts. They are called branches. And they are symmetrical. But they're symmetrical kind of, it could be over like y equals x, or it could be over y equals negative x. See, it could be symmetrical over here, or it could be symmetrical over here. But then we're going to have transformations too, so. Also, there are asymptotes. We have talked about asymptotes. What do we know about asymptotes?
It almost gets there, but it doesn't get there.
Right, it gets closer and closer and closer to it, but it never crosses through it. It does not touch it. So there's 2 asymptotes. There's a vertical asymptote and there's a horizontal asymptote. Anytime we have a vertical asymptote, it's x equals. The vertical asymptote is x equals. That's kind of like opposite of what you normally think. Vertical asymptote is always x equals. And the horizontal asymptote is always y equals. If there's no transformations, they're at 0. This is why we have an asymptote. What happens if I take this graph and I plug in 0 for x? You cannot have a number over 0. Go. What?
It's like grade school, but you can't have 1 east of 0.
Right, you can't. So that's why x cannot equal 0. Y cannot equal 0 because if I put a 0 in the y spot and I do 1 over x, if I take 1 and divide it by some number, I can never get 0. You can't take 1 and divide it by something and get nothing. So both x and y cannot equal 0. What are these graphs called?
Hyperbola.
Hyperbola. So we're going to graph the hyperbola. So we're going to start with f of x equals 1 over x. We're going to start with this one here. This is the parent function. And I'm going to make a table of values to start. And we're going to plug in numbers for x. What's something that I cannot plug in for x?
Zero.
Okay.
It's undefined.
So I know that there is an asymptote
X, Y equals 0.
at x equals 0. There's also an asymptote at y equals 0.
Whoa.
So what can I plug in for x?
And 1, 2, 3, 4, 5.
Only positives?
No.
Any number that's not zero.
Anything but not 0. So let's plug in, give me a number.
-1.
2.
-1.
What's that? Negative.
Let's plug them in. What happens if I plug in -8? 1 over -8. Negative and 8. So we go -8 down an 8. Well, that's kind of hard to graph. But
Are we able to put, I'd be going, are we able to put decimals on?
totally.
Okay,
Yeah, we'll do, after we fill those out,
okay.
then I'll talk about the decimal. Okay, -1, if I put that in, I do 1 over -1, that is -1. So we got -1, -1. That's a nice, easy one. We plug in 2, we get 1 over 2, that's a half. So I got 2 half. I didn't really draw my asymptotes in there. Okay, so Alex said, am I allowed to plug in a decimal? And the answer is yes, because what I talked about on the very first page is 1 over x is the reciprocal of x. Of x. So if I plug in 1/2 and I do 1 over half, that's the same thing as the reciprocal of a half. 1 over a half is the same thing as the reciprocal of a half. What is the reciprocal of a half? 2. So if I get a half for x, I go up 2 for y. Or if I plug in -1/2, it doesn't really matter where you put it. I did myself a lot of space. If I plug in -1/2, what's the reciprocal of -1/2? -2. So -1/2 is -2. And you can see it's starting to form the hyperbola curve. You just need to make sure when you connect the points that you graph that you use those asymptotes and it's getting closer and closer to the asymptote but does not cross over the asymptote. Also, I'm going to draw a do not do this. I'm going to draw one that is a do not do this. Do not connect these points and then like curve it out like it's a parabola. It has to get closer and closer to the asymptotes. It does not like get close to the asymptote and then go away from it. So that's a bad version of a hyperbola. Make sure you're just getting closer to the asymptotes.
Yeah.
And you don't need a whole lot of points. Just find a couple of points and connect them. They're always going to look like these branches, just maybe in different spots. So that is the parent function. That's the parent function. We still need to do 4 over x. So if I'm going to do 4 over x, 4 over x is the same as 4 over 1 times 1 over x. So that's using fraction rules. Remember when we multiply fraction, we go straight across? I would take 4 times 1 and 1 times x, and I'd get 4 over x. So 4 over x is the same thing as 4 over 1 times 1 over x, which is the same thing as 4 times 1 over x. And what does it mean, transformation-wise, if we have a number outside of the function? All the transformations we've done since the beginning of the year. What does that mean, Aaron? A vertical stretch. That means in my chart, I'm going to take which variable and multiply it by 4. The y variable, the vertical one. So in my chart, I'm going to take the y's and multiply them by 4. So all my y answers that I got, multiply by 4. And you don't have to do every single one. but you just need to do some of them so you can figure out what the shape looks like. So if I take -1 and I multiply by 4, I get -4. So my new ordered pair is -1, -4. If I take 2 and multiply it by 4, I get 8. So 1/2 is 8. If I take a half and I multiply it by 4, I get 2. So 2, 2. Well, I was seeing, I didn't do another easy ordered pair, but, which one?
4/4.
4/4. Which one are you talking about? You have a different point that I don't.
I put that
That's what I was confused.
Never mind.
If I take my -2 and I multiply it by 4, I get -8. So -1/2 is -8. The very first one, if I took -8 and I multiply it by 4, and I multiply straight across, that's like 4/1, and I would get -1/2. So -8 is -1/2. So we have some points. You need to know that it's going to curve around, and it's going to look the same in the first and the third axis, quadrants. If it's in the first, it's going to look the same in the third. So it says compare the two graphs. What could we say about the two graphs? What's something they have in common? What's something they have different? What do the two graphs have in common? What?
They have common asymptotes.
They have the same asymptotes. They both have the asymptotes at y and x equals 0, y equals 0. So they have the same asymptotes. What's something else that they have in common? Or maybe we don't.
Parent function. This whole one is the parent function.
Maybe they're the same parent function. That was in the direction, so yeah. They're going to have the same domain and the same range, which we haven't talked about yet.
All real numbers.
We're going to have the same domain and range, which we will,
All real
we'll
numbers.
talk about how to, nope, not all real numbers.
Nope.
No, not all real numbers. Because there's an asymptote there.
Everything but 0
For what?
for x and y.
So the domain is all real numbers except 0. The range is all real numbers except y equals 0.
Is there an easy way we could abbreviate it?
Which I will show you.
Except
No.
0.
I will show you the easy abbreviation in a minute. I'm writing it out right now because in the book they write it out. But I'm going to show you how you can simplify writing it out, totally like mathematically legal. I'll show you that too. Without making up your own stuff. All real numbers except y doesn't equal 0. Or I should say except y equals 0. So they have the same domain, the same range, they have the same asymptotes. What do they have different? What does that different?
Different points. There's one stretch.
They have different points because there is a stretch. Yes. So the second one, is it a g? Is it a g of x? Yeah, the g of x. So I'm writing even more detail than you may come up with on your own, but since it has a vertical stretch, the points are further away from the x-axis. So vertical stretch takes the points and like they're further away from the x-axis. So I was doing the notes on my own last night, and as I was like starting, I was like, man, there's a lot of information. But as we start doing it over and over again, I think it's gonna make sense and stick. It just seems like a lot right up front. Okay? So let's look at the next one. We're gonna graph g of x equals negative 6 over x. And then compare the graph with the graph of f of x equals 1 over x. So what are gonna be the asymptotes? And we'll just do for g of x. What are going to be the asymptotes for g of x? From 1 over x to negative 6 over x, are we translating? Or moving side to side or up or down? No, we're just stretching. So the asymptotes don't change. So what are the asymptotes?
Y equals
So I'm going to go graph those asymptotes.
They're already graphed.
They are, but people forget about them. So I'm graphing. And then we're going to make a table. And when you pick points to go in the table, what are some points we can't pick? 0. But you can pick anything else. You might want to pick numbers that are easy to graph. Like, what is a good number to pick in that you can divide by negative 6?
3 and 2.
Negative 6.
You could put in negative 6. You could put in negative 3. You could put in negative 2.
And then positive.
And the positives of those. You could put in 1.
Negative 3.
You can put in any of those. You probably don't even need that many of them, but
Yeah.
it's not that hard. So we got negative 6 over negative 6, which is 1. So negative 6 is 1. Negative 6 over negative 3 is 2. So negative 3 is 2. Negative 6 over negative 2 is 3. Negative 6 over negative 1 is 6. So negative 1 is 6. Can you, as I plot those, are you seeing that it is forming this branch?
A break.
One of the branches. Why is this branch in the second quadrant and not the first quadrant or the third quadrant?
Because it's negative 6. Negative.
So what does that negative do?
It reflects it over the something axis.
Uh-huh. That is a reflection in the x-axis. And then the 6 is a stretch.
Well, you won't really be able to tell by just like looking at the graph, would you? Because
No,
it would be
you would
the
not tell from looking at the graph. I was able to tell by looking at the equation because the negative 6 is not inside parentheses with the x, so I know it is affecting the y's. All right, I'm going to finish this. This would be negative 6. This would be negative 3, then negative 2, and then negative 1. Okay. That's down. So when we compare this to the parent function, what's the same? What's the same? The parent function I did not regraph because it was on the first question. What's the same? Do I need to regraph it? Huh? Asymptotes are the same. Here, I regraphed the parent function also, just in case we need it. So the asymptotes are the same. What else is the same? Say it again. Domain and range. So the same asymptote, same domain, same range. What's different? Okay, so what's different is there's a reflection.
And there's a stretch.
So it changed the quadrants. And then there is a stretch. I think it's struggling today. Stretch, so it's a further. I'm trying to write neatly, but my marker's not acting right. It might be, I should probably change that. Further away from x-axis. Right, now we're going to do translations with it. Translations. Oh. Okay, so here's the form. You've done it so much now. You notice in the bottom there's an x minus h, so the h is the horizontal translation, and remember it's the same. If it's minus, then it's actually right. If it's plus, it's actually left. And then out here we've got our plus k, that's the vertical. What is nice is you just apply those transformations to the asymptotes. You just apply those to the asymptotes. You don't have to apply that to every single ordered pair. You just apply it to the asymptotes. So, what transformations are happening here?
Left 2 and down 1.
Translate. So that means my asymptotes, we're going to have x equals, and instead of 0, we're going left 2. So x equals what's left 2 of 0. Negative 2. And then y equals, we're going down 1, so y would be,
Negative 1.
so we go over here and we put a vertical line at x equals negative 2. And we put a horizontal line at y equals negative 1. Now all you have to do is find a couple ordered pairs, just so you have some reference of how stretched it is. But you don't have to find 20 ordered pairs. Just find a couple of them and make those branches. So to find the ordered pairs, we'll just make a table. And then when you're going to plug things in, you're not going to plug in x equals negative 2. Because that's an asymptote. It's not going to work. If you do it, it's not going to work. So instead, let's plug in things that are left or right of the x equals asymptote.
Couldn't you, like, theoretically just plug in, like, the normal numbers you would plug in and then just translate those? Like,
You can, but that's doing
basically-
extra work.
but you just basically graph it from the asymptotes and just like that.
The problem is with the stretch of 4 and with the reflection of the negative being on top, you won't know what all the paired function points are. So it is just more efficient and faster just to plug stuff in. And then when I plug numbers in, I'm going to plug in numbers that make my denominator nice. Like I'm going to plug in negative 3. Why would I plug in negative 3? So I'll have negative 4 over, and I do negative 3 plus 2, and then subtract 1 from that. So on the bottom, I'm going to get negative 1. So I'm negative 4 over negative 1 minus 1, so which is 4 minus 1. So I just like purposely pick numbers that are easy. You don't have to pick easy numbers, you just have fractions to graph.
Why won't we just put this back?
Because you're about to do a chapter where you cannot do fractions on the calculator, so we're practicing right now to get you ready for that. You can just plug it on your calculator, but you will not get smarter.
Yeah, knowledge.
It's easy. It's just more.
Okay, but you won't get any smarter than a 17-year-old in high school. So when you're 25 and you haven't done anything on your own, you'll still have the mental capabilities of a 17-year-old.
Knowledge.
Just saying. Okay, negative 3, 3. Negative 3, 3, that's a point on there. What's something else that we could plug in that might make our denominator nice? 7?
I was just guessing.
No, it could be 7. but
Negative
it
6?
usually wants 7.
Let's plug in negative 6. So we plug in negative 6, I'm going to get negative 4 over. When I plug in negative 6, I get negative 4 minus 1. So you get 1 minus 1, which is 0. Negative 6 is 0. And in my opinion, that's good enough for that side. I can tell that it's going to kind of curve around and go towards the asymptotes from there. So I need some more points, but they can be on the right of the asymptote. What's another number we can plug in? What? How about 0? Can I plug in 0?
Yeah.
I can plug in 0 because what does that make my denominator for putting 0? So we have negative 4 over 2 minus 1. Negative 2 minus 1 is negative 3. 0, negative 3. What's another number we could plug in that makes our denominator kind of nice?
Oh, try negative 2. Oh, wait.
What else can we plug in? Yeah, positive 2. If we plug in positive 2, then we'll get negative 4 over 4 minus 1. So we get negative 1 minus 1, negative 2. And I think that's enough points to kind of tell where this branch is going. And they are symmetrical. The two branches are symmetrical. So if you figure out like some points over here, you can figure out the points over here by just kind of looking at it. They are symmetrical. Yes. I can't hear you.
Get tired of the same material.
She only teaches us twice this year, so.
Not this year. Last year, maybe. Because I had 5 sections of geometry last year. Kind of got boring. All right, domain. So our domain are all the x's. What do we know about the x values? Left to right. What do we know about the x values of this?
All real numbers except for negative 2.
So we look at our asymptote and we say x cannot equal negative 2. So our domain, we're going to say x not equal to negative 2. That would be the short version. When you write x equals negative 2, that means it's everything except for negative 2. So how about the range?
X not equal
Y
to y. Oh.
does not equal
Hey,
negative 1.
that's it.
Yeah.
Wouldn't that be swapped with X plus, because that would be the y point,
Nope.
or y.
You're doing the thing that always confuses everybody. This is when x is negative 2.
Oh, since that's the vertical, that's the vertical, x equals.
That's what x equals, because y can be anything. It changes there. right? Every single ordered pair has a different y, but x is -2 there. Okay, there are 3 student examples. So I'm going to stop talking, and you're going to start figuring things out and seeing where you have questions. I'm going to work on this for a little bit. Change it up a little bit. Okay, so I'm looking at this, and there is a translation down 2. So when I do my asymptotes, I'm going to have x equals 0. That one doesn't change, but then y equals -2. That one has a transformation on it. So I have one asymptote at x equals 0, and the other one is at y equals -2. And then I'm going to make a table, and I'm going to plug in points that make it easy for me. And since I have 3 divided by x, I'm going to choose numbers like -3, -1, 1, and 3. So I can divide 3 by those. So if I have 3 divided by -3 minus 2, -1 minus 2 is -3. And then -1 is going to be 3 divided by -1 minus 2, so -3 minus 2, -5. Now we'll connect those that branch. I plug in 1, I get 3 over 1 minus 2, so 3 minus 2 is 1. That's not right. What did I do wrong? What? Oh, that's what's wrong. I just grabbed it wrong. Thank you. I knew something didn't look right. All right, and then we put in 3, and 3 over 3 minus 2. That's 1 minus 2, so that's... And we have our branches. Then we have to write the domain and range. The domain and range are the same as the asymptotes, but with not equal to. So my domain is x is not equal to 0. And my range is y is not equal to -2. It's the exact same as the asymptotes. You just put not equal to. Yes. No, you don't have to. I am so that I don't lose anybody in how I got the numbers. But I could do some of that in my head. Good question. Okay, so the next one, what do we have? We've got asymptotes. And the x asymptote, is there a transformation for the x? Translation for the x, is there? It's 4 left because this is a +4. So my asymptote is going to be -4 for my x. So I take my asymptote and I move it 4 to the left. And then my y asymptote, is there a translation for my y? No, so that's still y equals 0. So I could, if I wanted to, right now, before graphing anything else, write my domain and range.
You could, but
Uh-huh. So I have my domain and my range. And then I need to pick a few points. Numbers that might be easy to plug in for this denominator might be -3 or -5. Because if I put -3 in the bottom, I'll have -1 over -3 plus 4. So I get -1 over 1. -1. -3, -1. So if I plug in -5, I have -1 over -5 plus 4. So -1 over -1, which is 1. That is telling me where my branches are. If you haven't written the asymptotes for number 4, write the asymptotes for number 4. You haven't written those asymptotes for number 4 yet. Write those asymptotes for number 4.
Can we plug in a number that makes this equal to 0?
That the denominator becomes 0? No. So you cannot plug in the asymptote.
Like -4?
You can't plug in the asymptote. Now, you can plug in 0. It's okay to plug in 0. Like for this one, I plug in 0 for this one. I'll end up plugging in 0. All right, asymptotes. Colin, what's that? Do it.
X equals,
I didn't hear you.
X equals 1.
X equals 1. You got them both?
Yeah, Y equals -5. Positive 5.
Positive 5, because remember the Y doesn't switch. It's the X that always switches, but the Y is always the same. So there's our asymptotes. We go over and we graph them. Remember, X equals 1 is a vertical asymptote, and Y equals 5 is a horizontal asymptote. What'd you say? Oh yeah, let's do that. Get the domain and range out of the way.
No. Why don't you just put D and R?
Because I want everybody to know what I'm talking about and not have to read my mind.
Oh.
Pretty good. If we put on a test like D and R, that
I would
fine?
probably write domain blank and you fill in
I do
domain.
it all
Yeah.
the time. I do it the whole thing.
And then we go to plug in some points, and you want to plug in something that makes the denominator easy. I plugged in 0, and I plugged in 2.
It's 1.
I plugged in 0, and I plugged in 2. So when I plugged in 0, I got 1 over -1 plus 5, which is 4. And when I plugged in 2, I got 1 over 2 minus 1 plus 5, which is 6, right? 6. Yeah. Now I'm going to draw my branches and then celebrate. Huh?
You're only
You can do more.
point.
But after you've done them a few times, you know what they're going to look like. So having 1 point is helpful, but you really don't need that many. As long as you have 1 in each quadrant. But
If it's got a 1 over, let's go up to the top. So if they add stuff on the top, so 1 over anything is going to be the parent function points anyway.
right, you could shift just the parent function points. Yeah.
Oh my god.
All right, let's take a quick brain break. Quick. Go to the wall.
That sounds so
I really want to get rid of
Okay, guys, we have like 2 more examples to do and a couple practice. Let's see if we can get these 2 examples done before lunch. We'll see. All right, the next one, sometimes there's a bit more involved. Like the other ones just had a number on top, and they called it A in the directions. Now we're going to have a polynomial on top. We're going to have a binomial on top that has an X value on the top and the bottom. To find the vertical asymptote, they have a formula. I do not like the formula. I like to just like think about it. To find the vertical asymptote, that's what X cannot be. For the vertical asymptote, the denominator cannot equal 0. For the vertical asymptote, the denominator cannot equal 0. So when we go to find the vertical asymptote, I write the denominator equals 0 and I solve it. Because the denominator cannot equal 0, I write x minus 3. This is the vertical asymptote. I write x minus 3 equals 0. And then I solve that for x. This is different than what the directions say to do, but this to me like is why we're doing a vertical asymptote, because the denominator cannot equal 0. If you just go by a, like I always do, negative d over c, I think that's harder to memorize. So how do I solve this for x?
Plus 3.
So I get x equals 3. That is my vertical asymptote.
Nice.
Now the horizontal asymptote, I am going to go off of their pattern, off of their trick. The horizontal asymptote is you take whatever's in front of the x and whatever's in front of the x on top and bottom, and you put them on top and bottom and say y equals that number.
Y equals 2.
So the horizontal asymptote for this one, I write y equals, and I'm going to put 2 over 1, because I'm taking what's in front of the x on top and what's in front of the x on the bottom. And I'm writing it as a fraction. So y equals 2 is the horizontal asymptote. So at y equals 2, I'm putting the horizontal asymptote. At x equals 3, I'm putting a vertical asymptote. And then, how do we find more points?
Plug in.
We just use a table and plug stuff in. We also have, oh, we might as well knock out our domain and range. Domain is not equal to 3. Range y is not equal to 2. There we go. There's my domain and range. So I'll make a table to find some points, and you can plug in any x's you want as long as it is not the asymptote. I plugged in 0, even though that is not the nicest answer. I just thought it'd be easy to plug in 0. Not like the nicest answer. So when I plug in 0, I do 2 times 0 plus 1 over 0 minus 3. So I get negative 1/3. 0, negative 1/3 is about there. But now I know that it's in this quadrant, so I can draw my branch over there. And then another point that I plugged in was I plugged in 4. So I did 2 times 4 plus 1 over 4 minus 3. So I chose 4 because I knew it would make the denominator 1. And I get 9. So 4, 9. And if that's not enough information to draw your branch, then you can plug in more points, but it will just look like that. Okay, instead of me showing you example 4, skip ahead.
Yes. Thank you.
Oh, I'm going to show you after lunch. Try 5, 6, or 7, which are just like this one. Find at least, at minimal, find the asymptotes that we just went over how to find. Find the asymptotes, the x and the y, the vertical and horizontal asymptotes for 5, 6, and 7. We'll come back to example 4 after lunch. So for the vertical asymptote, that's the x, we set the denominator equal to 0. So x plus 3 equals 0 because it can't equal 0. So what makes it 0? X equals negative 3. That's what makes the denominator 0. That's what the asymptote is.
Y equals 1.
Mm-hmm. And then the horizontal asymptote,
Just find the x.
for the horizontal asymptote, we put the numbers in front of the x's on top of each other. Y equals 1 over 1. So y equals 1. Can we try the asymptotes for number 6 and not totally finish graphing this one all the way? Okay. So the vertical asymptote, what do we do to get the vertical asymptote? What can't equal 0? The bottom cannot equal 0. So we do 4x minus 2 equals 0. 4x equals 2. So x equals half. So we just find where x is a half and make a vertical asymptote. Horizontal asymptote. We do y equals, and then how do we get the numbers? You're in front of the x's. So we do 2 over 4. So y is a half. But that's horizontal, so we gotta make sure we go horizontal. And we can plug in points and find the rest of the points. We can write our domain and range by using our asymptotes. Let's do the last one. Number 7, vertical. We do what for vertical? Negative x minus 1 equals 0, the denominator. And we solve it for x. So negative x is 1. So x is negative 1. Vertical. Horizontal. We do y, but where do we get the numbers? It's in front of the x's, the coefficients of the x's. So we do negative 3 over negative 1. So y is 3. All right, perfect. All right, example 4 is given the equation in the binomial over binomial form, but we're going to change it into the form that has the h and the k with the transformation. Okay, to change it into that form, it's so easy. You ready for this?
So we're not graphing it?
We're not going to take the time. In your homework it says graph it, so you'll graph it in your homework, but I just wanted to go over how you get it to this format, and then you can do all the other stuff that we were doing. Okay, to get into that form, you're going to divide. You're going to divide 3x plus 5 by x plus 1. And this is a review of something we've already done in previous chapters. We're going to do long division again. Let's go over how we do that. First thing you do is you look at x and you look at 3x. You put 3x over x. You put 3x over x and you divide it. What do you get when you put 3x divided by x?
3.
So I'm going to put that up here. After we divide, then you have to multiply, but you have to take 3 times both x and 1. So we have to distribute that 3 to the x and the 1. So 3 times x is 3x, and 3 times 1 is 3. Then, when you draw the line, you change the signs. Draw the line, change the signs, and we add it. Draw the line, change the signs. These will always cancel out, and what do we get here?
2.
So what we have is we have a remainder of 2.
Dose.
Do you remember how to write the remainder?
2 divided by 5. X plus
Right.
1.
So our answer when we divide this, we are getting 3 plus our remainder 2 over x plus 1. That is this equation. It's just in the other order. So I'm gonna rewrite it. So I'm gonna rewrite it as g of x equals, and I'm gonna write that 2 over x plus 1 plus 3. So what is our transformation from the parent function? What's our transformation? I'm gonna say left 1 first, but yeah. We would do left 1 and then up 3 units from our original parent function. Okay? So let's try one more of those. You skip ahead. It's like the last question in your notes, I believe.
That is.
Yep. Well, you have to graph it too, but we're just not going to take the time during class to graph it. I want you to spend all that time on your homework, not on the notes. So to divide, we're going to use log division. Go ahead and set it up.
Hey, what are you calling it?
We're going to do that one now. Yeah, because we went back and did number 4, so this is now number 8.
Is it the same?
It's the same thing, just different numbers. So what goes underneath the division symbol? Which of those?
2x plus 3. The numerator, right?
And then the x plus 1, what we are dividing by goes outside. So you remember you start by looking at the x and the 2x, and you put 2x over x. How many times does 2x go into x? I mean, how many times does x go into 2x? What does that give me? That gives me 2. So I put it up here. Then we distribute. We distribute the 2 to the x and to the 1. We multiply it. So we get 2x plus 2.
Minus 2.
Then when we draw the line, you change the sign.
It's flipped.
That's not. Flip is like this. That's not what we're doing. If you flip a plus sign, it's still a plus sign.
I'm just saying that.
Okay. And then I'm going to go ahead and add those together, and we get a 1 for our remainder. So this is giving me 2 plus 1 over x plus 1.
No, flip it.
So g of x equals, and I'm going to reorder it, 1 over x plus 1 plus 2. And we're going to write our transformation.
Up to like 1.
Translate 1 unit left and 2 units. All right, for your homework, it is in the book, but I have printed out some graph paper, so you could do like your word and then graph it right next to it. Okay. I'll put up the homework assignment in just a couple, 30 seconds or so. I'm going to do this.
You're putting up the answers?
Yeah, totally. Some people are so hard. Okay, let me see. We need 1, 2, 3, 4, 5, 6, 7, 8. 7, 8. I forget how many graphs we need. I'll go look in a second. Well, I'll just give you 8 graphs for now. Maybe I can't remember if the 8 or more. But it's just 8. They were smarter than us.
We're gonna have 3 days.
Yeah, I don't know if I counted that right. They're kind of stuck together. What? You have 6. You take it. Okay.
Oh, it's